Hi everyone, welcome to ADHD Guy Wants to Stable. We'll study biomechanics today. So this is the lecture one. This is a very small introductory lecture, very easy. So this one will go to study that rigid body mechanics and this vector coplanar concurrent blah blah blah. Momentum torque is not there, but anyway, we'll go through it. So what will actually biomechanics is? Biomechanics is the study of body movement, the motion, the the behavior it does it possess, and we will match it through the classical mechanics of physics. So there are two type forces: coplanar and non-coplanar. Coplanar are the forces which are happening in the same plane, like this one, and a non-coplanar, no, not like the multiple plane or something like that. There are this type of forces are actually divided into planar, coplanar, and concurrent, coming at the same point, coming and going through the same point. If you have to define concurrent forces, that would be if all the line of the axis, axon. Suppose this is a force is coming. I won't say that the line of forces is just like this. It will origin from this. It can be also like this. Okay. So if you have to extend the tail of the forces, even that is coming at a certain point, and there are another forces is generating, then we can also say that their forces are actually concurrent. So if you have to mention it, always two forces will have in a same plane, which always concurrent. Because even though this is a force and this is a floor, our paper is a plane, so they are actually on the same plane. We can say that their forces are actually concurrent. Can we? Yes, we can say, because if we extend the tail, this coming at the same point. So every two forces on the same plane is always concurrent. That's a good fact. Collinear coming, collinear, if you have to extend both of them, are actually single line. Coplanar but non-collinear coming at the same point, but they are non-collinear. And this is interesting. Coplanar like polar, direction is same. But they're parallel, but kind of anti-parallel. Parallel, parallel. Okay. Collinear, concurrent, parallel, and this is general. Acha. Mhm, mhm, mhm. If you have to extend this, none of them are actually coming at a single point. See, that's why they are non-concurrent. Anyway, and that is interesting thing. Another interesting thing that if there can be a concurrent forces, multiple concurrent forces, but they don't have to be coplanar like this. Can you visualize it? Very interesting here. And we have studied this, and if there is a two forces, that we can actually always find the resultant forces, and if there is multiple forces like this one, we can see F1, F2, F1, F2, F3, F4. They have finded two resultant forces of this force and then another complete for resultant forces of this force. And this angle, we have a special term for that when we the resultant force is making it with our x-axis. Okay, and there are actually when we say the single forces, what kind of forces it does make it when it comes to the motion. There is lower rollers, rollers force. There are friction, but the motion actually applies very fast and very efficient when compared to the motion applied. This is the kind of say we can say the most efficient production of motion when it comes to giving the forces. And there is rocket where you just complete sector of the sphere, not sphere, we can say spin, something like that. Frictionless surface. Frictionless surface, I mean, it doesn't have any friction. So if you just apply a single little bit of friction, it will keep moving in motion. And force with a line of action. Okay, when hinge, very easy. And this is fixed support, like that complete that same material, the same body, some part of the body is inside them. And this is very interesting, rough surface. So rough surface, if there is an object, okay, what actually holding it, the friction actually, the friction is actually holding it. So if the friction is can compensate the gravity, if the force has to if the object has to fall down, it will make a coupling force. This will make a coupling force on this side, and this will if that force can be compensated by the friction. Think about it. I will mention again. If the gravity, gravity products an coupling backward, downward, and that force can be compensated by the so friction, then the surface will always be in impact. It will always stand. So the factor that actually make it interesting is that if more the height of the object, more the coupling force, so more the friction has to be it has to produce, so that it has to keep it intact, keep it still, keep it stand. So that's why it's very hard to keep a tall object intact in a single surface. So in an ideal rough surface, the object will never fall down. Because why? It will always compensate the couple force generated by the gravity. Very interesting, yeah. On a direction, we don't know if it is x s y, so we can actually find out by making it resultant, converting into two resultant forces. Uh, Couple, we know couple, tada, tada. This is couple. Yeah, you can actually go through this if you want to go through this, and if you want to get to know more, create some example of we are actually went through the dipole thing. Yeah, these are kind of dipole thing. Mm-hmm. Mm-hmm. The see kind of the number of forces actually it applying. The weight is apply here. The weight is applying this side. So if you have to given a center of gravity, this will kind of here like, because this force heavily amount of force is generating, and this guy's force is generating. So the center of gravity will be like from here. And this is a very good concept of conservation of momentum. You can actually calculate m1v1 is equal to m2v2. Very easy. M1v1 is equal to m2v2. Okay, great. So this is a very interesting sort of thing. A girl is running in an uplifted surface, elevated surface. So what are the kind of forces? So obviously, can we erase it? We cannot erase it. Na? So obviously, if the girl is climbing, she has to this force, apply this force backward. So after this, what kind of force is actually generating? If she is generating this force, then the friction will push her forward. This is the force responsible for always walking, for always running, because the friction is enable us to do that. The friction is actually pull her forward, and there is air that will pull her backward, and that is called actually drag force. Well, we actually another word it called air resistance, and that is the x-axis component of gravity. That is y-axis component of gravity. So then you have to forget this if we have actually find out, and that is the normal. Well, of course, she has to matlab her feet has to lie on the ground. So of course yeah, normal will apply. So always remember when someone is running, the friction is responsible for making us forward for the forward movement. Great. That's the kind of angle we have actually went through this. Very interesting. Ligament is the part of the body which joint the connects the bone with the muscle. Here, bone with the muscle, and cartilage is the part of the human body which connects the bone to bone. And seborrheic fluid is the reason who actually have we have less friction with the bone to bone, and the bone actually doesn't damage. So that's why old people have joint pain. Kind of forces very interesting: tension, compression, shear, tension. Yeah, sorry, tension, compression, shear. I will ruin this. This is the number way we can torture our bone. See, the amount of damage produced by shear force is very, very, very damaging. Friction, after you apply force, after external force is applied, or you you make it internal, the force which go with the motion is kind of the friction always happen. This is interesting. This is homework. Huh? This is homework. Do it. Take a screenshot and do it. So this is a kind of neck movement we have discussed hypertension, hyperlexion, and yeah, they have given a disease that actually occurred by if we do not have any good posture on our neck. Well, plus is the disease which is caused by bad posture on our neck. So always keep maintaining a good posture. Uh-huh. They have actually gave a very good design of oh my god, see, after a accident what actually happened to your neck bones, the ligament get damaged, nothing much happened with the necks because the necks has been designed so flexible that it will not damage, even though the ligament will damage, and the ligament can actually can I mean the rate of healing of ligament is very fast. So this is the, you can see the number of muscle actually is used while lifting a body. So that's why go to gymming is very important. Like look at this number of muscles: your biceps, your tripod, your teresa major, your gluteus, your femora, lesser cellula, tibia, labilla, femoris, abdominis, anterior dorsal. Like, see, look at this thing, man. This is really interesting. And when we are standing, though, they have actually got. So they have mentioned a one center of gravity of a single leg. So when we'll just go through the simple fact, we'll go over the deeper part. So when actually someone is running one step further, so center of gravity is always lies on the uh, front leg. So that is interesting. But when we are standing in normal position, center of gravity always lie on this point and always fall in between our legs, in the middle of the legs. So the body movement is always unique to people to people. So they have actually replaced the what do you say, the fingerprint mechanism. I mean, so that actually we can unlock our security to our body movement, because our body movement is unique to people to people. So that's all. That is it, guys. I hope you enjoyed it. So that was kind of introductory lecture. We'll go deeper from next lecture. Yeah. So this is interesting. Yeah. Bye then. Bye. Have a happy lecture. You can skip it, by the way. You can go through with 2x or so probably.